Welcome, dear students, to an interesting part of Max Mind where we'll be looking at reinforcing particular mathematical concepts using interesting analogs, that is, using interesting examples from related fields, and of course, in most cases, we would be dealing with physics and in this particular video we'll be looking at uh, the equal functions and of course I am positive that uh, you people have gone through the particular video dealing with equal functions and is quite clear with it, so that we can go forward and thoroughly understand what is going to be taken in this particular section. So we are going to look at equal functions by means of physics. That is a very basic physics, and equal functions. Looking at equal functions by using basic ideas of physics. That's what we are going to do in this particular video. And now, what are equal functions? We know that when we state that a function f of x is equal to another function g of x, it simply means that uh, the domain and the range both the functions are equal. What I mean is that when you the input value, that is suppose the input value of function f of x, if I call it x1, and if the output value is y1, now input and output simply means input, of course, is the element which we entries into the function to carry out a particular mathematical process, and of course what comes out of the process is y1 or the output. So if the input value of f of x is x1 and the output value of f of x is y1, and that of g of x, the input value is x2 and the output value is output value of g of x is equal to y2, then now equal functions mean that x1 is equal to x2 and y1 is equal to y2. So what's the difference? The difference is in the process, and I'm quite sure that all of the dear students have gone through our previous video dealing with equal functions and have looked at the examples, very simple examples given there, and have understood what exactly is meant by this the equal input values and output values and the process being different. Now let us look at the whole idea by taking some elements of basic physics. Now we know that one of the fundamental working principles in mechanics is dealing with the difference between distance and displacement. Now, displacement, suppose there are two points A and B, and now displacement is naturally the shortest distance between A and B, or you could call it how far away a particle has moved from an initial point. That's a point. So if a particle is moving from point A to point B, then naturally in most of the cases it ought to be the shortest distance. So this is the displacement between A and B, and actually distance is the total I mean the total distance covered when a point vehicle or a body moves from point A to point B, or suppose there are three persons, and I'd call it persons P1, P2, and P3. And of course, the first person is moving from point A. He's going through certain hill-like places, and crossing a river and something like that, and reaches point B. So this is the route of person 1. Person 2, I mean, this person 2, he's quite less adventurous. He wants to reach point B without much hurdles, and naturally he chooses the shortest route. So P2 is the person P2 chooses the shortest route, and naturally that's the displacement between A and B. And there's the third person who is actually more adventurous, and he maybe reaches a lake, maybe has a picnic place, things like that, and after some time reaches B. So you can see that there are three persons starting from point A, and all of them are reaching point B. But the thing is that the displacement of all the three persons are equal, but the distance covered is different. Now, the interesting part is that what if we equate distance with the process, that is the mathematical process which we carry out on a particular element, and if we equate the displacement with the output, we can see that it's quite an explanation from physics for equal functions. Now, how can it be done? Now we know that as far as if we are dealing with three functions, f of x, g of x, and h of x, then all these three functions would be equal. That is, f of x would be equal to g of x, and g of x would be equal to h of x if all the outputs if the outputs are y1, y2, and y3, and their inputs are x1, x2, and x3, then naturally x1 should be equal to x2, and that should be equal to x3, and the outputs also should be equal. Only the process would be different. That is so. That's why they are called equal functions. The process means what we do. I mean, if you take the general equation for, or the general representation of a function, that is f of x is equal to y, then the process or the mathematical operation which we carry out on element x, which comes from the domain, to get element y, which belongs to the codomain, or which and which is the output. That's what I mean. So f of x is equal to g of x is equal to h of s only if x1 is equal to x2 is equal to x3, and y1 is equal to y2 is equal to y3. It simply means that the example of the distance and displacement can be used here. So that is so. You have the 2 points, and you have the three persons who travel in three different routes, but of course their displacement is same. So but the distance is different. So if you equate the distance covered by each person to the process, and this is process 1, so this is process 2, and process 3. We can see that as far as the process is concerned, in all the three cases it's different. That is, the distance taken is different, but the displacement is the same. So if you consider the initial point as the input, or x, the process as the distance covered, and the final point reached, or the displacement as the output y. We can see that the distance displacement difference can be used to explain equal functions, and I hope the viewers enjoyed and understood this particular section, and I would like to solicit your response, your feedback in this particular case. Thank you.